Geometric sequence. How do we find the common ratio? Okay. Yeah, so you need to find what it multiplies by. Obviously, the easiest way is to divide. So 108 divided by 36 is what? 4? Is that what somebody said? 3? Okay, and then do 36 divided by 12. So when we're talking, if it's geometric, you have to check every one. 36 divided by 12 is 3. And then 12 divided by 4 is 3. Okay, is that geometric? Yes, why? They're all the same, so it is considered geometric. So you're going to say yes. Okay, what is the common ratio? 3. Okay, number 3. Negative 125 divided by 25. Negative 5. 25 divided by negative 5. Negative 5. Negative 5 divided by 1. Negative 5? Okay, do not, this is just my advice, do not look at them and assume because your first two are negative 5 that the last one is negative 5. Okay? We have seen that for geometric you have to check every single one. Okay? At the point when you get one that is different, then you can stop. Okay? But check every one. So this is going to be yes, negative 5. Okay, the next section on there says find the next 3 terms in the sequence after the last given one. What is the last given one? Negative 375. Okay, so you're going to say negative 375 divided by 7, negative 75. Boys, why are we talking?
Not me, that's the one that's calculator had a bunch of zeros at the end.
I don't care. Well, it's every day. Like, I don't, it's not that bad. Okay, what is that? 5? Okay, so we know our common ratio is 5. So now you're going to say negative 375 times 5. Negative 1875. Negative 9375.
Negative 4687.
4687. 85.
875.
Okay, so every time you're saying that term, times 5, times 5, times 5. 3 times. Okay, if we look at 7, we got 32 divided by 16. Huh? What is that? 2 or negative 2? Negative 2. Okay, so now we're going to say 32 times negative 2. What is that? Negative 64 times negative 2. 64, 128 times negative 2.
Negative 236.
Okay, I purposely put these 2 particular problems on there rather than a just straight up positive one. Okay, I can tell you from grading your sheets, these are the 2 that you guys get wrong. Okay, you either you get the number part right, okay? You get this numbers right, you forget the negative, okay? Or you forget that it goes negative, positive, okay? So pay extra attention to, when you're doing your quiz, that you are making sure that you're doing negatives or positives, okay? Find the term named in the problem. What is the formula? We need a formula for this, so make sure it's on your paper. You remember?
It's the first, so -1.
Good. Okay, so it's A parenthesis R to the what? Close, so it's gonna be N minus 1. Now, you do know, what does the A stand for?
The first.
Yeah, and that's what Chase was talking about, -1. So this is our first term. What is our R? Well, in general, what does it stand for? The ratio. And then the N is the term, I don't know, name, the term you're trying to find. If you want to write extra long, you're more than welcome to. Okay, so that's the formula. Okay, and we talked about calculator differences. If you, depending on the calculator that you have, you need to do the 12 minus 1 in your head. Okay? So, we know that our first term is what? -1 parentheses. Okay, and then you need to find your R. The R is 2, so you'd say 8 divided by 4, which is 2. Okay, so we're going to put the 2 there. N minus 1, 12 minus 1. Okay, and type that in your calculator, see what you get. Okay, Musa, you have one of these older calculators, so you should type in this to the 11th power. You can't do the 12 minus 1 on yours. Well,
Negative.
Initial answer.
because you need to say a negative, not a minus. What is it?
82,000.
-2.
Yeah. Sorry, -2,038.
2048.
Yeah.
You know it's gonna be easy.
Okay, 11, we're going to be doing the same way. What is our first term? 2. Our common ratio, so you're going to say -250 divided by 50. -5. Okay, so we're going to say -5 to the what power? 9 minus 1, or what? 8. Okay, depending on what calculator you have. Shit, sorry. What you got, Chase?
78250.
Somebody double check that. That's right? Okay. Okay, unfortunately, on this particular quiz, there's not too many notes I can give you. You kind of either know it or you don't know it for a lot of it, okay? So, the next page in particular, you either know it or you don't know it, okay? So if you don't, then go back through and kind of restudy some of the stuff that we're using, okay? So, let me see which side I was gonna do. Okay, I'm hopping around today, so make sure you're on the same number than I am. Okay, 13 says, Awan wants to know what the favorite sport is among students. To find out, he asked everyone he sees after school leaving basketball practice. Okay, identify the intended population and determine the potential sample bias. So, what is the intended population? students, okay? That's what he's trying to figure out. He wants to know among students, and it tells us in here, among students. Okay, what is the potential sample bias? What's wrong with this one?
He's asking at a specific sport.
Yes, okay, so he's asking, as kids leave basketball practice, what do you think their favorite sport is? Basketball, probably, okay? So, somewhere on here you say, he's asking as students leave basketball practice, okay? Where could he ask instead?
Gym.
At the gym, okay, as students enter the building, as they enter the cafeteria, okay, any of those would be sufficient, okay? So if it's one of those questions and asks you, how can we make this an unbiased sample? Those would be some examples of how you could do it unbiasedly, okay? Okay, 14 is the next one I'm gonna do, which is over here. Ryan wants to conduct a survey at a nearby mall to determine which are the mall's most popular stores. How could you choose a sample that is unbiased?
Asking people as they walk in.
Asking people as they walk in the mall. Because I can't do it at Macy's, because chances are if they're shopping at Macy's, maybe that's one of their favorite stores. Okay, so on 14, right, as they're entering the mall. Hello? Okay. All right. Okay, we're asking as entering the mall. Uh, 15 you're gonna do, okay? 16, there are 3 candidates, oh no, you guys are gonna do 16 too. 17, sorry. So she's recording butterflies she saw on her daily runs every week. So every week she goes for a jog, okay? The numbers are 1, 8, 2, 2, 5, 6, and 4. Find the mean, median, and mode of the data. Okay, so start finding them. When you got one, let me know. What you got?
The mode is 2.
The mode is 2, somebody agree?
Yeah.
Okay, perfect. I need the median and the mean.
Median's 8.
The what?
Median's 8.
Median's 8? There's no way. Okay, so the median, we put them
4.
in order, so it's got to go like 1, 2, then 4, then whatever.
Yeah, it's 4 there.
4. That's okay. Okay, and then the mean.
4.
Huh?
4.
4? Somebody agree? Okay. I don't care. It's yours. You'll find out when I grade it. Because Trayvon's grinning like he don't know. He's just saying yeah. But I didn't see it typing, so you guys get that wrong. Blame it on him. Okay. Which measure or measures are appropriate to accurately summarize the data? So, is there an outlier? Well, what is an outlier? We talked about this yesterday. What is an outlier? What do you mean? Be more specific.
Like
What is considered a weird number?
higher or lower.
By a lot. Okay, so an outlier is something that is way higher or way lower than the rest. That is considered an outlier. It's kind of like an outcast. He don't fit in with the rest of the numbers. So, is there an outlier? Look at your numbers. Is there an outlier? Okay, 8? Is that what we're going with? Do you feel like 8 is drastically bigger or smaller than the rest? Okay, so sometimes there's not gonna be an outlier. Why is 8 not?
Because
It's kind of
It's only like 1 or 2 away from 6, okay? It would have to be like 15 would be an outlier, okay? 100 would be an outlier. He sticks way out. 8. So, which measure or measures accurately summarize the data? You can put they all do. There's nothing wrong with this data, okay? If the number was like 100, is that going to make our mean go up or down? It's gonna make it go up. What if we have all our numbers and they're like in the 90s and I have a 0? Is that gonna make my numbers go up or down? Down. So if I have an outlier that is low, it drops our mean. If I have an outlier that is high, it higher our mean or makes it go up. Okay, so those are the only things that you really got to answer with that. If there's an outlier, what does it do to the mean? And that's the part that you would put right here, the outlier and what's going on with the mean. Okay, 18, we also covered this yesterday. The graphs show the number of t-shirts sold at a baseball tournament for 2 years for 2 different vendors. So we got 2 different vendors. We'll say me and Chase's t-shirt sales. Okay? So we're going to compare me and Chase's t-shirt sales. So we can say graph 1, that's Chase's shop. Okay, Chase's shop starts out at 20 and goes up by 20s. Okay? My shop, okay, starts out at 60 and goes up by 20s. Do the graphs misrepresent the data?
Yes.
Why?
One starts at 60, the other starts at 20.
Okay?
they're equal the same.
Whose graph is going to look bigger or smaller? And this is where you may have to kind of draw it to see.
Number 1.
Take 1,
Yeah, it starts at 20.
okay?
Where's her
So if we did like this, okay, we did 2 graphs. This is Chase's. Where does Chase's graph start? He's graph 1.
20.
His starts at 20 and goes up by what?
20s.
20. So then the next number would be what? 40, 60, 80, 100, right? We could say week 1, 2, 3, 4, 5, okay? And then my graph starts where?
6?
At 60 and it goes up to 100. What does it go up by? 60, 80, oh shit, 100. I was trying to erase with my finger. Okay, 100. So we could say at week 1, we're at 60. Okay, at week 2, we're at 80, and at week 3, I'm at 100. Okay. There's the difference between me and Chase's graph. Whose looks bigger?
Yes.
His. It looks like he sold more t-shirts, did he? No, we both sold 100, right? Okay, so whoever graph starts lower looks bigger if they're on the same scale. Okay, whoever graph starts lower, their graph is going to look bigger because they're going to have more points. Whereas mine, they only started, it's like millionaires, right? Do they count ones
No.
typically? No. You never see anybody flex in their money with a bunch of ones. You look stupid, okay? Unless you're going like somewhere. The camera's on, so I don't know. Gotta keep it PG, okay? So nobody flexes a bunch of ones, okay? Millionaires, they're gonna flex hundreds or something. Okay, so how does this, do the graphs misrepresent the data? Yes, okay? And we're gonna say graph 1 looks what?
Like it's level? Bigger?
Bigger, okay? So the smaller the graph starts out, the bigger the graph is gonna look, okay? Okay, correlation, just for you guys have it, okay? Positive correlation, they're all going up. Negative, they're all generally going down, and the none is all over the place. Okay, so I'm looking at the left side. Is this positive, negative, or none?
Negative.
Negative. Hi, bud. Okay, what about number 3? It's none, and I will go back to these notes if you need them. And number 5. is a none. Okay, so we got negative, none, none. If you're doing the odds, I know I went fast. Okay, hopefully you did the stuff when I was gone. If not, then you probably don't know what the hell I'm talking about. Okay, the last page. Determine whether it's a correlation or a causation. Okay, the one note, because even Hanson was like, I don't necessarily get it. Okay, causation is going to happen no matter what. Okay, now, let's think about this. The more hours I work, is your pay going to go up? No matter what, right? No matter what, the more hours you work, the more your pay is going to go up. Does the same work for effort? The more effort I put in, I'm going to get the results.
Not necessarily.
Not necessarily. And that's that key word, okay? So my car could be broke on the side of the road. Does that mean I ran out of gas? Not necessarily. Maybe I got a flat tire, okay? There are plenty instances where it may or may not work. So you're probably typically, a general rule of thumb, a lot more things are going to be causation than, or correlation than causation. Causation means it is going to happen for everyone. That is a guaranteed result. Okay? So I want you to think about, hey, shush. Okay, I want you to think about that when you're doing these. Is it guaranteed to happen for everyone? Okay? So reading more increases one's intelligence. So no matter how much I read, I'm going to be smart? No, there's people that read all the time and they're dumber than a box of rocks, right? Okay, that's a correlation. If it was that true, everyone would be a genius, right? All you had to do was go to the library. Okay? Number 9. The speed you drive and the amount of fuel you use. Causation?
Yeah.
Why do you feel like that?
Because the passenger, it's like,
It takes more power to go forward.
Yeah, it does. Like, okay, no matter how much gas I use, everybody runs out, right? Everybody's gas tank goes a certain amount of miles. Okay, no matter what, okay, eventually you're going to run out of fuel. Okay, that's for everyone. It is a causation. Okay, when there is more protein, okay, in an athlete's diet, the athlete scores more points in the game.
Correlation.
That is absolutely a correlation, okay? And the same works with pretty much any sport, okay? You can eat, you can be the most healthy, you can practice the most. Does that mean you're going to be an all-star player? Absolutely not, okay? Unfortunately, no matter how much you practice, you may or may not get any better at the sport, okay? The rest is for you guys to do. Go through, get them done. If you do not finish, okay, please try to bring it back before 7th period, okay? That way I can have it graded.